Hello students, welcome to the interesting chemistry. If you want to enjoy classroom teaching experience from your study room, then please watch my video of the interesting chemistry. I have made up so many videos and I would recommend you to watch my video of IUPAC if you want to know about the basics of the IUPAC system of nomenclature. Then please watch my video. You will get to know all the rules and regulations of the IUPAC. Today I am going to explain this list of these 7 types: the atomic size, atomic volume, and atomic radius, covalents, and so on. First off, the atomic size or the atomic volume. Atomic volume you know. But how will you measure? How will you measure, or how will you find the value of atomic volume or the atomic radius? It's not so easy task to find the value of atomic radius or atomic size. It's very complicated. Then you can ask me why. There are 2 reasons behind it that to measure the atomic size or the atomic radius is very complicated. The first reason is the size of atom. The size of atom is too small to measure the atomic radius. As you know, the size of atom is 1.2 angstrom. It is the size of atom, size of atom, 1.2 angstrom. And sometimes you will find the size of atom in your book 120 picometer. 120 picometer, it is 1.2. So I want to remove your confusion about this unit of the size of the atomic atomic size or the atomic radius or the bond length. This is angstrom. 1 angstrom is equal to 1.2 and 10 raised to the power minus 8 centimeter. It means 1 angstrom is equal to 10 raised to the power minus 8 centimeter. Again I can write here 1.2 into 10 raised to the power minus 10 meter. I have converted this centimeter into meter, so the power becomes minus 8 to minus 10. This can be written as it is 1.2 into 10 raised to the power 10. Both are these all values are equal. Now I am coming to multiply this value by 100 by 100. When you multiply this value by 100 by 100, this 100, when you multiply this 100 will this 1.2, it will become 120 into 10 and divide by this value by 100, so the power will be minus 12. So it is here. It is the same thing I am coming. So 10 raised to the power minus 12 equal to the picometer. So it can be written as 120 picometer. I think that you have understood about the confusion of this angstrom, meter, centimeter, and the picometer. This was the size. So I was telling you the size of the atom is very small, so it is very difficult to measure the atomic size or the radius of the atom. First thing. Second, the atom is very unstable. How will you measure? The atom is unstable. Due to the instability, it is very difficult to measure the size of atom or the atomic radius. Third one, the most important thing, that is the third one, that the atom, in an atom, the electrons revolves around the nucleus. This is and these electrons are found in the form of electron E clouds. Electrons around the nucleus found in the form of electron cloud. They have the electrons or the electron cloud doesn't have any sharp boundary. There is no sharp boundary. There is no marked boundary. That's why we can measure this distance by any method. So due to the absence of this sharp boundary, we can't measure the radius of the atom. But so there are due to these difficulties, due to these complications, we cannot find the size of the atomic radius in this. But our scientists found a practical approach to measure the size of the atomic radius. They test these. Where do you find the stable atom? If I ask you that where do you find the atom in a stable condition, in a stable position? One thing in a molecule. One thing in a molecule. Molecule. In molecule the atom is stable. And or in a metallic lattice. Both. As you see, as you see in the metals, solid metals, all the atoms are attracted with each other and they found in the form of solid, so their atom is stable. So in this way, when we find the molecule in the stable position, now I am taking the example of molecule. This is the molecule. In a this is hydrogen molecule, to make you understand. Both the hydrogen atoms are bonded with covalent bonds. This is covalent bond. And again, the model of the hydrogen is I have drawn the model of the hydrogen atom. These are both. These are H1. This is the hydrogen atom, and this is also atom. It is assumed in a molecule, diatomic molecule, that both the hydrogen, the clouds of the electron cloud of both the hydrogen touches with each other. So these are the electron cloud touches with each other. This is hydrogen. Now, with the method of spectroscopic method or with the help of the X-rays, we can measure or we can find the value of internuclear space, internuclear distance. And this internuclear distance is called as bond length. And half of this internuclear distance is called radius. Now, as you are measuring the radius in a covalent covalent molecule, so this radius will be called as covalent radius. This is covalent radius. Not it, this is covalent radius. Now, I will give I have written in here for your simplification. In a covalent single bonded molecule, the condition is, if you find, suppose this is S2, this is Cl2, this is F2, this is O2, this is N2. All the three are bonded with single bond, Cl, N, but this O is with double bond, or N is the N triple bond. So in the multiple bond, you cannot find the real distance between internuclear distance. So only in the condition is single bonded. So I have written in a covalent single bonded molecule of an element. Of an element. What do I mean by this element? It means both the atoms are similar of the same element. This is hydrogen, this is hydrogen. This is hydrogen, there will be different. The atoms are different, then you can find it. So, in a covalent single bonded molecule of an element, I think that you have understood about my reading this. The half of the nuclear internuclear distance. The half. This is the internuclear distance. This is the high internuclear distance, and the half of the nuclear distance is called covalent radius. I think that you have understood what do you mean by covalent, because I have taken the covalent bond, so it is called as covalent. Now think about this covalent radius, this atomic radius, both are the synonym of each other. Synonym. So you can find with the help of this covalent radius, you can find the value of this atomic volume, or you can measure the atomic size. Then I have concluded this all. Now come to the metallic radius. What do you mean by this metallic radius? In a metal lattice or in a metal crystal, the same thing will be applied in a metal. Suppose these are the metals, this is metal, these are the atoms of the metals. So again, you will find here the internuclear distance. So in metal, you will say that in a metal crystal, the internuclear distance, the half of the internuclear distance of two adjacent or two closest atom, which is separated by the core of the lattice, or called the metallic radius. So this was about the metallic radius. So in the same manner, when you will describe the metallic radius, in the same manner you can describe the metallic radius. So I have explained what is metallic radius, covalent radius. All are the similar, all are the synonym of the. Now I am coming to the next. That's the van der Waals radius. That is van der Waals. These topics oftenly asked in your examination, having the weightage of half marks or 1 mark, or half and 1 marks. So please try to understand what I am going to make you understand. Now I am coming to the van der Waals radius. What do you mean by van der Waals radius? So before knowing the van der Waals radius, you should know about the van der Waals forces. In the neutral molecule or the neutral atoms sometimes attract each other with a very weak forces. Suppose the hydrogen. So it is a gas hydrogen, and you lower the temperature and you lower and increase the pressure. The hydrogen atom will come close to each other. The hydrogen molecule come close to each other, and there will be a attraction between the molecule of hydrogen will be evolved. That weak forces. Due to the creation of that weak forces, the hydrogen atom will come close to each other, and finally they will get liquefied. In the same manner, take the example of the inert gases. They are found always in an atomic state. When the argon, the temperature is lower, pressure is increased, the atoms of the argon will come close to each other, and then there will be a very weak force is created. That's why each atom of the argon will attract with each other. These forces are called the van der Waals forces. These forces always will be created in a neutral molecule or a neutral atom. So now I have taken the example of iodine. You will find iodine is in a solid state because all the iodine molecules are attracted to each other with the help of the van der Waals forces. I have shown you in the figure. This is I2. This molecule is I2 and this molecule is I2. So these are the I and this is I. This is I and this is I. Both the molecules are attracted with each other. Both the molecules. Due to the van der Waals forces, these van der Waals forces, weak forces, very weak forces. That's why when iodine is heated, iodine converts into direct gas without liquidifying. The trend is that when solid is heated, it will convert into liquid, and liquid then it is gas. But iodine, the solid iodine, get converted into direct gas. Such type of elements called the sublimating substance. So iodine has the property of sublimation. So that's on heating, these van der Waals forces diminishes, end up. Then every molecule is free. They will not attack to each other. So they are free. So they are converted into gas. Now I am coming to here. So again, this was about the van der Waals forces. Now I am telling you the van der Waals radius. Take example of two molecules of iodine. They are in a solid state, like in the metallic, showing metallic radius. So they are writing. So here the internuclear difference of the two nearest atom of iodine of different molecules, not the same molecule, but different. This molecule of this molecule and this is another molecule. So the interdifference, because both the molecule of iodine are attracted by the van der Waals forces. So the internuclear distance of these two adjacent atoms of different molecule is called the half of. Now come to the term half of the internuclear distance of the closest atom of different molecules is called the van der Waals radius. This is called. So I have explained. I have explained very well. So I think that you have understood about the van der Waals. Now I am coming to the ionic radius. Ionic radius. It is very ionic radius. So again, the same thing of this is ionic. When the radius of ion is called the ionic radius. When you measure, when you find the value of the radius of an ion, that is called an ionic radius. So as you know, there are two types of ions. One is cation. And another is anion. So take about the cation. Take about the cation. Don't go to my handwriting. I am telling you, repeating you, I am telling you about this. This is not it cation. how the cation is formed. Suppose this is Na having the electronic configuration of 281 and 11 proton in the nucleus. When one electron is removed from this sodium atom, when one electron is removed from sodium atom, this is electron and it is removed from here, then the remaining electronic configuration of sodium will be Na. So this ion is also Bs, the nucleus of 11p. This is also, so both the atom and ion has the similar nuclear charge, 11 proton and 11 proton. So now compare the size of the atom and its cation. Understand, try to understand. The size of the atom will be bigger than the size of the cation. So always the size of the cation will be smaller than the atom. Why? Now you have to explain why. So here, take the example of here are 11 protons and here 11 electrons are attracted by the 11 proton. Here 10 electrons are attracted by the 11 proton. So again here compare. Again I am using the term ENC, which I have explained in my previous video. Effective nuclear charge. So the effective nuclear charge will be increased because here are 11 proton, 10 electron. Here are 11 proton, 11 electron. So this 11 proton, it will attract the 10 electron, more attractive force. So the size of the cation will decrease. Hence the cation are smaller in size than the atom. If you come to the example, suppose this is Fe and Fe you leave 2 and this is Fe double positive and then one electron is Fe double positive to minus 1 electron, then it becomes Fe triple positive. So how will you tell the size of this is Fe, this is Fe, this is Fe double positive and this is Fe triple positive. So as the positive charge of cation increases, the size of the cation also decreases. Take it care. As the removal of the electron increases, the size of the ENC will increase. Hence the size of the cation will decrease. So I think that you understood. You can give the example of the Fe. I have taken some examples. Suppose this is Na. You can write here the size of the Na is 1.57 angstrom. This is size of the Na, and the Na positive, the size of the Na positive is 0.98 angstrom. You can give the example. I have taken some example from your book. So it may be changed. You find the difference in this data according to your book. But I am giving the size of the Na. Sodium atom is 1.57 and the sodium positive is 9.98 angstrom. Sorry, 1.57 angstrom and sodium positive 19.8 angstrom. And this is about the size and sodium. This size 1.7 and this is smaller. Now I come to the anion. Now I am coming to the anion. So size of the anion, what will happen to the size of the anion? It is just opposite to the size of the cation, because F, it is F, fluorine atom. The electronic configuration is 2,7 and the protons are 9p, and when it gains 1 electron, so the F ion will be formed. So now come to the electronic configuration of F ion, it is 2,8. 2,8. Now think about the ENC effective. The effective nuclear charge, don't want to explain to you how the effective nucleus charge will decrease, because 9 protons have to attract 10 electrons and 9 protons have to attract 9 electrons. Here 10 electrons, here 9 electrons. So the charge of the fluorine atom will increase. This is the increase. So think about the cation, the forming the cation, the charge will be decreased, and after forming the anion, the charge, the size, I have okay, the forming the cation, the size will be decreased, and forming the anion, the size will be increased. So this is the increase in this way. So here I think that you have understood. I have noted the F, it is minus F 1.36 angstrom. The F negative, it is the 0.64. The atom, the size of this atom is 64 angstrom. Atom, it is neutral, and the size of the negative is 131.36 angstrom. So please note it. These are about the size of the. So I have explained the effect of the size on forming the cation and cation. Now I am going to explain you the isoelectronic series. What do you mean by the isoelectronic series? What do you mean by the isoelectronic series? The ions that have similar number of electrons or the similar electronic configuration are called isoelectronic ion. Isoelectron, I will tell you about this series, but I am telling you still that isoelectronic ion. If this one is F negative, this one is F negative, here this is sodium. Write the electronic configuration. There are 10. The number of 9. 1 electron is gained by fluorine. So here the electronic configuration of fluorine ion is 2,8. Do you understand? The nature of the 2,7. It has gained 1 electron. So 2,7 will become 2,8. And this sodium, this is 2,8,1. And when 1 electron is lost by the sodium, then it will be sodium positive, then the 2,8. So the electronic configuration of both the ion is similar. So these ions are called isoelectronic ion. I have given you the example of fluorine. Now come to the series. So to find out the series of the isoelectronic ions in your periodic table, how will you take any example of the inert gas, helium, neon? You take the example most neon. The number of neon is 10. Take the example of 11 sodium. Take the example 12 magnesium. And here in the minus, take the example of the 9th fluorine. Take the example of oxygen 8. These are the. Now cancel the sodium, neon. With the help of the neon, you find out sodium, magnesium, fluorine to the rightward and to the leftward. Now make the oxygen double negative, F negative, and Na positive, and magnesium double positive. Oxygen number 8, 8 plus 2, so the electronic configuration will be 2, 8. Because two electrons are added in the 8, so 10, and 1 electron is added into, so it is also 2, 8. It is 1 electron is lost by sodium, so from 11 to it is 2, 8, and 2 electron is lost by, so it is 2, 8. So this is the series of isoelectronic ion. Now it is asked that write the size of the descending and the ascending order of this electronic series. So you can write here, this one is the biggest, and to this one is somewhat smallest. This one is again smallest, and this one is this is the size of because the cation has the smaller size and the anion has the bigger size. The charge will decide here. The charge is 2 negative, so the size will be more bigger, and the here in this way. Now I think that you have understood about the isoelectronic series and their size. So now come to the next, periodic tense. Now I am telling you the periodic tense. What do you mean by the periodic tense? Though in the periodic table, the properties of the elements changes with some special patterns, with some special tense. So I have to discuss about the atomic size in the periodic table. You know, this is the periodic table. This is about the period when we move in a period from left to right. The size of atom always decrease. This is the size. This is the size. This is the size. Sorry, this is size. And this is size. And last, this is helium, neon. This is neon. Suppose this is lithium, beryllium, boron, carbon, nitrogen, oxygen, and this is fluorine. So when we move from left to right in a periodic table, the size of the atom, the size of the covalent radii, the volume of the elements of the atom will decrease, and finally the size of the inert gases. Helium, neon, argon, they have fulfilled outermost orbital. So the size, their size will automatically increase. So here up to fluorine, the size will decrease, and this inert gases, the size of the inert gases is different. Now come to a group from upward to downward. So here, this size will be increased. Size will be increased. This is the size will be increased. Now, I will explain the why do the size. This have a particular trend in the periodic table. So I have given factors affecting the covalent bond or the size or and these all terms. First, the nuclear charge. The nuclear charge. The lithium has 3 protons. This boron has 4 protons. So the nuclear charge is in fluorine. In one, suppose nitrogen 6, 7, and fluorine. This is oxygen. Fluorine has 9 protons. So in this case, the nuclear charge is increasing. But the lithium 2, 1, beryllium 2, 2, nuclear charge is increasing, but the adding electron, the entering electron will enter in the same cell the same cell. So the increasing of the nuclear charge will attract the effective nuclear charge will increase. As the effective nuclear charge increase, the size of the atom will decrease. The size of the atom will decrease. Now come to, so the nuclear charge, this is nuclear charge, or you can see effective nuclear charge is increasing through the radius. Now the number of cells. Here when you come to this size, here in this way, this size, here lithium is 21, lithium, then sodium is 281, potassium is 2881. So the number of cells, the number of orbits increases. No doubt the nuclear charge is also increases due on the increasing the atomic number, but the number of cells is increases, so the charge of the so the size of the atom will increase. Think about it. Third point, that is most important. In this case, only the anti-electron is adding in the second cell. It doesn't create any new shielding effect. That's why the ENC of the nucleus will increase and they will attract more attraction, so the size will become. But here, as we are going to reduce it down, the number of internal cell increases. The number of cells increases. So in these internal, due to the presence of these internal electrons or cells, the shielding or the screening effect will increase. Hence the ENC of the nucleus will decrease. So the size of the atom will increase. These are the 3 points about the factors affecting the covalent radii or the size of the atom. This all about the today's video I have explained with my full capacity. I hope you will like my video, and also you will share this video to your friends. That's why they can also get some help in learning by this video. So please like my video, subscribe my video, and share to your friends this video. I think that this video are very helpful for you. So that's all for today. Thank you very much.